Hi folks, we're going to take a look at number 7 from page 170. So here we have the equation of a cubic function with some unknown coefficients. And what we want to do here is find these coefficients such that these conditions are satisfied. And the way the conditions are given is they tell us that the function has to increase up to the point -318, then it's going to decrease to 1, -14, and then it's going to increase after that. Okay, so when we talk about the increasing and decreasing behavior of a function, we're talking about the sign of the derivative. So here, the function's derivative has to go from increasing, so positive, to negative, which is decreasing. Now, the only way function can change sign, or the only place a function can change sign, is at a zero or at a discontinuity. But here, since this is a cubic function, the derivative is going to be a quadratic function. Hence, there's going to be no discontinuities to the derivative. So the only place that can happen is at a 0 of f prime. So this tells us that f prime at -3 has to be equal to 0. In fact, this is in an earlier section. Now we know that this actually means that there's a maximum value at -3. Okay, and similarly, if the derivative has to go from, or the function is going from decreasing to increasing at this point, in other words, the derivative is going from negative to positive, okay, that means again we must have a 0 discontinuity, but since it's a polynomial, it has to be a 0. So f prime at 1 is also equal to 0. Okay, and this is the information we have to determine the missing coefficients. Okay, so we know we'll have to work with derivatives, so I'll find the derivative of this thing here. So it's 3x squared. So a times the derivative of x squared, so plus 2ax plus the derivative of bx is just going to be b. Okay, and I notice here the c doesn't appear, so I'm going to start working with this scenario here with the derivative. So I know that f prime at -3 needs to be equal to 0. Okay, so let's put -3 into this function. So we have -3 squared is 9 times 3 is 27. Okay, here we have 2 times -3, so minus 6a plus b is equal to 0. Okay, and what we have is -6a plus b equal -27. Okay, so that's one equation. Let's see what happens when we put the derivative at 1. We said also has to equal to 0. Okay, so here we've got, so 3 times 1 squared, so we've got 3, 2 times x, 2 times 1 is 2, so plus 2a plus b also has to be equal to 0. Okay, so here we have 2a plus b equal -3. Okay, so I'll call that equation 1, and equation 2 we'll call this here. So put this underneath, we have 2a plus b equals -3, and we'll eliminate the b by subtracting. So -6a minus 2a is -8a. The b's are eliminated, and here we have -27 minus -3. So -27 plus 3 is -24, and so we have that a is equal to 3. Okay, and now I'll use equation 2 here. So here we know that a is equal to 3. So from equation 2 we can determine b. So we have 2 times, here we have 2 times 3 plus b is equal to -3. So b is equal to -3 minus 6 is -9. Okay, so there's our second one. Okay, and now we just have to find c. Okay, but here, since we already have a and b, we only need to use one of these points. So I'll say that 1, -14 looks a little easier. So we know that f at 1 is equal to -14. So here f at 1 will just be 1 plus, we know that a is equal to 3. So 3 times 1 squared is 3. B is equal to -9. So -9 times 1 is just -9. So minus 9 plus c is equal to -14. Okay, and so c is equal to, so -14 plus 9 is -5 minus 1 is negative 6, minus 3, negative 9. Okay, you can check that out. Pretty sure that's correct. Okay, and there you have it. We have our three missing coefficients. Okay, so just to recap here, the information was given in such a way that we had to do a bit of interpretation. Okay, so by saying that the function was increasing to that point and then decreasing, that meant that the derivative had to go from positive to negative. In other words, the derivative had to have a 0 there. And similarly here, if the derivative had to go from negative to positive, it had to have a 0 there. Okay, so that's how we found these two properties, which we used to find a and b, and then we used one of those points to find the c value, which doesn't appear in the derivative. Okay, that's it for this one.